All right, hey Titans. Today we're going to take a little trip down memory lane and revisit some similar triangles with proportions. But it fits right here because we're going to do it with right triangles, and that's what we've been focusing on with our trig and Pythagorean theorem. So a little bit more right triangles combined with proportions. First, we have a new vocabulary word. It's called the geometric mean. You might remember the arithmetic mean from IM1, and that was basically where you just found the average of two numbers, right? So if I averaged 3 and 5, I would add those together, divide by 2, and I would get 4, right? 4 is halfway between 3 and 5. Geometric mean, however, is a little bit different. Instead of adding numbers, you actually end up multiplying and taking a square root. But essentially, it's basically an average where we're going to multiply two numbers, and like I said, take the square root. So if we are finding the geometric mean of 2 and 8, we are simply going to multiply those together. So 2 times 8 equals 16. And then to get the geometric mean, we're going to take the square root of 16, which equals 4. So the geometric mean of 2 and 8 is 4. For 4 and 9, we're going to multiply 4 times 9 to get 36. And then we're going to take the square root of 36, which equals 6. So the geometric mean of 4 and 9 is 6. So instead of adding and dividing by 2, we are multiplying and taking the square root. We're going to come back to that idea a little bit later in this lesson. But first we have one additional vocabulary word. It's altitude. So maybe you've heard altitude with flying a plane and how high the plane is in the air. It's a little bit different than that. This particular altitude is when you draw a segment from a vertex of a triangle, and you draw the perpendicular line, or the line that is perpendicular to the opposite side. So basically, you're going to this vertex, and you're making sure that the line you draw forms 90 degrees with the side across. So if I go here, if I go 90 degrees to the side across, those are both called the altitude. So altitude, 90 degrees, goes from one vertex to the opposite side. All right, so we're going to investigate this a little bit, and I'm actually going to take this off so you can see a little bit better what I'm about to do. So we're going to start with a rectangle. I've got a rectangle. But what I'm going to do is I'm going to turn this rectangle into two congruent triangles. So what I did was I went to one corner and I drew the diagonal to the other corner. And then if I cut this out, I will get two triangles that are exactly the same size. Voila! Wow, I cut that so fast. All right, so I've got my two triangles, and if I move it around, they are exactly the same size. All right. So if I take this triangle, which is definitely a right triangle, right, because I have 90 degrees there. If I draw the altitude, which, go ahead and do it this way. If I draw the altitude that goes from this vertex here, perpendicular to this side here, that's called the altitude. If I now cut that, this one I didn't have already cut, so I'm cutting it now. I have now taken that original triangle, right? It was one triangle. And when I drew the altitude, I split it into two new triangles. So I've got this medium-sized one, I've got this little one. And together, these two form that original triangle. Now, I've got the original triangle, right? And then I cut that to get the two new pieces. So how many triangles do I have now? 3. Okay? Well, something interesting happens with these three triangles. If you take the original triangle and you draw the altitude, right, like we did, we drew the altitude, the two new triangles that get formed are actually both similar to the original. Now, how can I prove that? Well, let me go ahead and take these and turn them. And it might be kind of hard to see. Hopefully I got this in the camera here. But I now have three triangles that are the exact same shape. And I know this because they all have 90-degree angles, right? All three have a 90-degree angle. And then if I push them up, they all share this angle up here. They all have that exact same angle, and that's the reflexive property with angles, right? Or if I spread it back out, you can kind of look at it and you can tell that this angle, and this angle are all the same. If I actually line it up. So these three triangles are similar by angle. Okay, so there's our original triangle. We drew the altitude to cut it into two new triangles. So now we have three triangles, right? We've got the little one, the medium one, and then the original big one. Well, the right triangle altitude similarity theorem tells us that if we draw this altitude, we now have three triangles that are all similar. So all three are similar. Right? And we know that if triangles are similar, or if any shapes are similar, then it means their sides are proportionate. So guess what we're about to do? We're about to do some proportions. All right, so there's my original triangle again. We've got the altitude right here. It's going from one vertex to the opposite side at a 90-degree angle. And again, how many triangles are there? Three, not two, right? You might go, oh, there's 1, 2. But if I break it out, there's my medium one. There's my little one. But what else do we still have? We've got the big one, right? So we have three triangles, and we know that if we turn them, like I did with the paper, all three triangles are similar. They all have the 90-degree angle. And then their acute angles, well, actually, they're all acute. If I follow the short side, this angle, if I follow the short side, this angle, and if I follow the short side, this angle, those all are congruent as well. Which would also end up meaning that angle, and that angle are congruent. And if our angles are all congruent, our triangles are similar. Okay, so now that they're all similar, we can now start to solve for missing pieces. So the first way I'm going to show this is by drawing out all three triangles. So I'm going to draw this little one. And when I draw each of them, I'm going to draw them all facing the same direction. So there's my little triangle. Then I've got my medium triangle. And I'm going to go ahead and reorient it so that it looks like the other one. And then I've got my big triangle, the original. And I'm going to draw that the same way as these other ones. And now I'm going to label the pieces that I know. So if I go to my little triangle, I know that the short leg had a length of 8. And I know that this longer leg right here had a length of 12. The hypotenuse of this little triangle, I don't know, so I'm not going to mark it. In the medium triangle, this side right here is the shortest side of the green triangle. So my shortest side is 12. This side right here is the longer leg, or the medium side of the green triangle. So that's this side here. And then the hypotenuse, I don't know what it is. And then if I go to the big triangle, I don't know the shortest side, I don't know the medium side, and the longest side, I would have to add those two together. So the hypotenuse is 8 plus x. All right, so when I go to solve this problem, I notice that I have two parts of this triangle, I have two parts of this triangle, but I only have one part of this triangle. So guess what? We're not going to use that triangle. We're just going to use the two triangles that we have two pieces of. And now we can go ahead and do what we did with similar triangles. We can set up a proportion and solve. So I could do medium side over short side. So medium over short. Or the way I have them oriented, I could say height over base, right? Or vertical part over horizontal part. So if I set up the fraction 12 over 8, what fraction would I set up from my second triangle? Well, yeah, if I did 12 over 8, the second one would be x over 12. And so from here, we have a proportion. We can cross multiply. 8 times x is 8x. 12 times 12 is 144. Divide by 8. And x equals, I'm pretty sure that's 16, but I'm going to double check. 144 divided by 8. Oh, glad I checked. It was 18. All right, so x equals 18. Okay, let's go ahead and try another one. So again, the key on these problems for now is to be able to draw the three triangles and then label each side that we already know. So I'm going to go ahead and draw this one. You know what? I'm going to go ahead and draw it that same direction. Okay, and on this triangle, I know the shortest side is 9. I know this medium side is x. I don't know the hypotenuse. When I draw the medium triangle, all right, I'm going to face it the same direction as this one. My shortest side is actually up here, right? I have to kind of turn it. My shortest side is here, which is x. My medium side, or my other leg, is 16. And the hypotenuse, I don't know what it is. Now at this point, I could just stop because I can already see that I have two parts of two triangles, and that's enough to solve for x. But just for practice, if I drew the big triangle, do I know the shortest side of it? No. Do I know the other leg? Well, that's right here. No. But do I know the length of the hypotenuse? I do. How long is the hypotenuse of this triangle? Well, we've got to add the 9 and the 16. So this hypotenuse would be 25. But that's the only thing I know from this triangle, so I'm not going to use it. I'm going to use these two. And because I know that the altitude of this right triangle will form three triangles that are similar, I know that these triangles will be proportionate. So if I set up my first fraction as x over 9, what would my second fraction be? Yep, 16 over x. All right, here's where we get to see the geometric mean in action a little bit. When we cross multiply, x times x is x squared. Hey, we're going to take a square root. That's part of the geometric mean. So x is actually going to be the geometric mean of 9 times 16, which is 144. And finally, to get x squared, or to get x by itself, we'll take the square root, and x equals 12. So again, we draw out the triangles, we label the pieces of the triangles we know, and then we set up a proportion and solve. All right, there is a useful shortcut for this that'll make these problems really quick and easy. At least the problems like this one and the one before, where we have the altitude and then the two parts of the big hypotenuse. So if we do have that, we can use the geometric mean, because the altitude will actually be the geometric mean of the two parts of the hypotenuse. In other words, the first part of the hypotenuse divided by the altitude will actually equal the altitude divided by the second part of the hypotenuse. Or the way I teach it, boom, 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 boom. Piece over altitude equals altitude over piece. Right? Part of hypotenuse over the altitude equals the altitude over the other part of the hypotenuse. Or altitude squared, right? Because if we cross multiply, we get altitude squared equals part 1 of the hypotenuse times part 2. So here's how we can do it nice and quick. If I recognize that I have the altitude, right? This is the altitude. And I have both parts of the hypotenuse. I've got 4 and 9. I know that the altitude squared will equal part of the hypotenuse times the other part of the hypotenuse. 4 times 9. Or if I was to set this up as a proportion, I could do piece over altitude equals altitude over piece. So 4 over x, 4 over x equals x over 9. And if I cross multiply, I get x squared, and then this diagonal would be 4 times 9, or 36. So then finally, I can take the square root, and x equals 6. Now we could take all 3 triangles, we could draw them out separately, we could list all the parts, we could find the 2 triangles that have 2 parts, and then do a proportion, like we did on the first 2 examples, or we can use our geometric mean. So again, here's another example of the geometric mean. I recognize I have the altitude, and then I also have the 2 parts of the big hypotenuse. So we're just gonna go boom, 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 boom. Or 4 over 8 equals 8 over x. So 8 squared equals 4 times x. Or as we said, the altitude squared, 8 squared, equals part 1 of the hypotenuse times part 2, so 4 times x. To simplify this, 8 squared is 64. And then to get x by itself, divide by 4, and I get 16. So x equals 16. All right, here's a problem without the altitude. And so in this particular Edpuzzle, I'm not going to give the shortcut for this. There is a shortcut, and your teacher might give that shortcut to you and actually list the shortcut at the end of the Edpuzzle. But I want to make sure we understand how to set up the 3 triangles, list the different parts, and then set up a proportion. So in my little triangle, that's the littlest one. And actually I'm going to set, I'll draw right here. So in my littlest triangle, I don't know this leg. I do know that this leg, the shortest side, right? The shortest leg is 36. And this time I actually have the hypotenuse. The hypotenuse is x. Then when I go to my medium triangle, I'm going to draw that a little bit bigger. The shortest side of that, I don't know what it is. The longer leg, or the medium side, I actually do know what that is, because I can do 100 minus 36 to get 64. And then the hypotenuse, I don't know what it is. So we only know one part of this triangle, which means we're not going to use that triangle. But then I go to the big triangle, and if I draw that one, oops, this one isn't going to look much bigger, but we're going to pretend it's the big one. The big triangle, I know that this side here is x, and that's the shortest side, right? So the shortest side was x. The longer leg, I don't know, so I don't know how long this leg is, but I do know the hypotenuse, right, which is adding these together, or it's already given to us right here. The hypotenuse is 100. And again, what do I know about these 3 triangles? they are proportionate, right? So I can go ahead and take this triangle here where I have x over 36, which is hypotenuse over shortest side. And I'm just going to set up that same fraction for this triangle here. The hypotenuse is 100, and the shortest side is x. And you might notice x times x is x squared, so we are going to have a geometric mean. 36 times 100 is 3600. And then take the square root, and the square root of that is 60. So the length of this side here is going to be 60. All right, one more example. We're going to draw out the small triangle, the medium triangle, and the large triangle. So I'm going to start with my small triangle. Hey, it's over here now. That's okay, doesn't matter. So my small triangle. My shortest side is 4. My longer leg, or the medium side, we don't know. And the hypotenuse, we don't know. So we only know one part of the littlest triangle, which means we're not going to use it. If I then go to the medium triangle, I'm going to redraw it facing a different direction so that it matches, right? All three will look the same and make it easier. The shortest side of this medium triangle, I don't know, so I don't know the shortest side. The medium side, or the longer leg, I do know is 9. And the hypotenuse, right, across from the right angle, the hypotenuse is x. And then in the big triangle, so I'm going to draw my big triangle. The shortest side of it, right here, we don't know. The medium length, or the other leg, we know is x. And then the hypotenuse of the big triangle is this whole side here. So it's not 9, it's not 4, it's 9 plus 4. So we're going to go ahead and get 13. So now based on this information, based on the triangles we drew out, we know we're not using this one because it only had one piece. But what equation could I use to solve this problem? Well, that's right. If we take medium side over hypotenuse, right, medium over height, we could do 9 over x, which would equal x over 13. And then we can go ahead and cross multiply. X squared equals 9 times 13, which I believe is 117. Double check. Good. And then we need to take the square root. Which, why don't you tell me, what's the square root of 117 as a decimal? Well, square root of 117 as a decimal is 10.82. So the length of x is 10.82 units. All right, one word problem example. And this one's one where we can use our original shortcut, which will make this nice and quick. Maybe you'll decide to go do this outside today, who knows? All right, so you are standing 15 feet from a tree, so we know that's 15 feet. The distance from your line of sight to the ground, or basically the height of your eyes, is 5 feet. And we are trying to find the height of the tree. Well, in order to find the height of the tree, I need to still know how much this part of the tree, or how tall that part of the tree is. So you might notice that this 15 right here is called the altitude, right? This is going from one vertex of the triangle, and it's forming 90 degrees with this opposite side. And we know that the altitude squared is equal to part 1 of the hypotenuse times part 2. Or I could do the proportion, hypotenuse part 1 over the altitude equals the altitude over part 2 of the hypotenuse, right? Boom, 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 boom. That's the way I like to teach it. Boom, 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 boom. It's the boom, 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 boom problem. Anyway, all right, so 15 is my altitude, so that's gonna go in those two spots, which is why we really just get altitude squared, right? Because 15 times 15 is the altitude squared. And then my first part of my hypotenuse was 5. The second part I don't know. So I'm gonna do 15 times 15, which is 225. And that is equal to 5 times x. And finally, I can divide both sides by 5, which I believe gives me, no, it's not going to give me what I thought it was. Let me double check that. 45. All right, so x equals 45 feet. Okay, so we use the geometric mean, right? We used our shortcut, boom, 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 to get that this portion of the hypotenuse will be 45 feet. Let's take it one step further though. How tall is the actual entire tree? Well, it's not 45 feet because that's only from here up. We have to add in the 5 feet, right? So if we do 45 plus 5, the tree is approximately 50 feet tall. The tree is 50 feet tall. All right. So I told you I would show you the shortcuts. If you want to take a picture of this and try to make sense of it, to have a shortcut to use, feel free. But the only shortcut that I really teach in my class is piece of hypotenuse over altitude equals altitude over piece, right? Boom, 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 boom. Or E squared equals C times D. If your teacher teaches you the other shortcuts, great. But that's all we're going to do today. So, a little bit of similarity, all right? A little blast from the past, combined with some of our right triangle stuff. So, fun times. Go Titans.